Hello, welcome back to another edition of Higher Education Today. I'm your host, Stephen Roy Goodman. I'm here at the University of Cape Town, where we're going to be speaking about electricity. And some of you may know that there's been a tremendous electricity crisis in South Africa and other places throughout the world. And so this is going to be a sort of electricity 101 discussion. So we have with us two guests today, Tariq Kahn, who runs the Energy Institute at the Cape Peninsula University of Technology, and Komla Folly, who's a professor of electrical engineering at UCT. Welcome to both of you. Tariq, if we could start with you.
Sure.
People turn on a switch, a light switch. It goes on or off. And many people say, well, the light switch is on or off. How did that electricity get to that person's house?
Yeah, it's electricity is a form of, if one were to give an analogous explanation with not too much technical detail, a form of transportation of energy. Basically what we need the electricity for is the heat and the light, because that is the old representation of the four classics, the water, the fire, the earth, and the air. And of course, the fire is what made man technologically superior and which gave us the edge. And we needed the fire for the heat and the light. And electricity is that modern representation of the fire. It is literally our sources of heat and light within our homes and within our industry. And in that sense, I would say if one switches on that light, when one throws that switch, it gives us the ability to have that energy without the concomitant negative parts of it, which is the smoke, the ashes and everything else that goes with it. So it's really a very convenient form of getting the same heat and light that we would get from fire into our homes. And I don't think we can ever return from this phase back to what we would call the proverbial dark ages. It is here for us to use, to enjoy, and we must find alternative and all sorts of means to keep it going.
Well, that's what I was going to ask you about. Let me ask Komla if you could speak about that. So about the sources of the energy, and let's assume that that's right, in terms of bringing the energy to our homes. What are the sources of energy here in South Africa? Where does it come from?
Okay. So in South Africa, we have these three types of sources. One is fossil fuel. So for example, coal. So most of the power stations are coal-based. Coal-fired power stations. We have nuclear. It's the only country in Africa that has nuclear power plants, and it's actually in Cape Town. Yeah. And then recently we start having renewables. Okay, so renewable, we have solar, for example, wind, hydro. These are renewables. So when at the power station, then we generate those electricity. So electricity is transformed from mechanical form to electrical form, right? So if you have coal, now you have to boil that water and the steam that run the turbines and to produce electricity. So when the electricity is produced, you have to transmit that to the users. Okay, so you need transmission line. So we produce electricity at normally very low voltage. We can say 11 kilowatts, which is 11,000 volts, and then you have to step it up in order to be able to transmit that over long distance. Okay, so that transmissions in South Africa here we have the highest is 765 kV. So that is transmitted over long distances, and then in our home to use that we have to step it down again. So we need transformer, we need substation. When it's reached the substation, we step it down and then go to the distribution. That's what we call distribution. So when the power is generated, it's transmitted because the long distance you need high voltage. Otherwise, the system is not efficient. We have a lot of losses if the current is too high By stepping up the voltage, then we can reduce the losses and we have efficient network. And then at the distribution side, that's where we can give it to the loads, to the customers like us, industries, and so on. So that's how it's transmitted. So when we get the power, normally we think, it's taken for granted because we don't have to do much. We think it's very easy, but it's very complicated process for us to receive that. One of the reasons is because this electricity, normally you have to have a balance between the loads, the demand, and the generation. If it's unbalanced, then we are having trouble. So, yes.
Well, let's talk about that balance in terms of the load. So for an American audience, South Africans use the term load shedding. We would say it's a power outage, but in South Africa, they say that it is load shedding. So let's talk about the load shedding. So you're shedding some of the use of it by turning off the power for 2 or 3 hours at a time. Why is that happening? Does that mean that not enough electricity is being produced, or that there's a problem with the transmission?
When the supply and demand are not matched, there's inefficiencies that can be one of the main things that we wouldn't want. We wouldn't want say we have a small petrol generator for backup power, and we turn the generator on, we filled it up with petrol, and it is producing electricity. And I was about to run my power drill and a couple of other tools with it, and I got a phone call, and someone says I must go pick up a family member at the airport, and I leave the generator on. I went to go pick up that person. 2 hours later, I'm back, and the fuel have been used up, electricity has been produced, but nobody used it. So obviously that is not a situation that one would want in a large major power system. We wouldn't want to burn fuel and nobody's actually using it, because electricity is on the wire, it's there, but there's no load. So you're going to still burn the fuel. So that is not a good thing to have. And everybody can see that that is a wasteful process. On the other side, if we have the demand very high, and again, I'll give an analogy with that, with a petrol generator. If you switch a couple of power tools on and add your kettle and your stove and everything else, and you turn it all on, you'll actually hear that generator making a very cumbersome noise, as if something is now, you are overloading it. And in that case, with a larger power system, that could lead to severe problems, which, and these power systems have massive steam generation turbines. And those turbines itself, if there's any oscillations or vibrations or anything in terms of the load, can actually go all the way back and damage the actual power generation equipment. Not just talking about the cabling and the generators, but actually the mechanical parts can actually also be affected. So these are things which one wouldn't want. And therefore, if you have a load that is if the demand is too much, you need to actually reduce it in order to switch those power tools off, switch those kettles off, and actually get the generation to be performing at a more optimum level. So that would be sort of an idea of why load shedding is needed. I need to switch some things off, and then I will hear the system stabilize.
But why couldn't, for instance, we say, well, every day between midnight and 3 in the morning, we turn off things, rather than say, well, today it's at 10 in the morning and tomorrow it's at noon and the next day it's at 3 o'clock?
So this load shedding is needed because power system is very typical. It's very, because we need to have balance in real time, okay? So you have to have balance between the load and generation in real time. You cannot say, okay, wait a little bit, like if I call you telephone, for example, you can say, okay, I'm not going to take it now, it's fine. But with power, you have to generate. So under normal circumstances, if there is a lot of load, then you have to generate more power. But the situation we are facing in South Africa is that we don't have enough generation. So when we generate power and the load is more than the generation, that the frequency is going to change. And that can create what we call blackouts. If the blackout, that is large scale power outage, and that's not good. So that's why we have to have load shedding. So when we shed the load, we reduce a little bit the pressure on the system so that we don't have the widespread blackout. Like if you remember in the United States, recently, even in Texas, there was 2020, that blackout, it takes days before you restore the system. In 2003, it was also the highest blackout in North America, and we don't want that. So that's why the grids operators are doing this load shedding. So they shed a little bit load to release the pressure on the system. Otherwise, we are going to have a large-scale blackout, and that can take weeks before we get the power. And so this is because if I'm having load shedding all the time at the same time, it's not very convenient. So it's like a rotating. So the system, the city has a rotating plan so that if you have it today at 2 o'clock, tomorrow it will be another time. And also it depends on the stages. Okay, so if you have stage 1, so like 1,000 megawatts of load shedded, then maybe you have power outage only once, once a day. If it's stage 6, then you have more power outage. So it's what a schedule that they have made.
Yeah, it's a carefully balanced management of the available energy to the demand, and it also tries to be a little bit more fair in actually sharing that power outage for certain segments of the community, because so that is one way of doing it, and I think it's working quite well. It's inconvenient, but it's better than the alternative, which is as Komla said, the whole scale blackout, because to restart the power system in that case is quite something. An equivalent to that would be your motor car battery that has you've run it until it's flat. There's nothing; it won't start your car. What you really need now is an equivalent power source to restart it. So where's that going to come from? So that means our electric power system has to be restarted stage by stage, one system at a time, and synchronized, because this is the other part of it. We are actually talking about alternating current electricity. And alternating current means that all the equipment needs to be synchronized together, because if they are not synchronized, you will create electric faults, potential short circuits between lines and equipment, and that will again trip the system. So it's a much more delicate beast, if one were to call it like that.
Well, speaking of that delicate beast, I'm hearing something from both of you that I was not expecting. That I was expecting you to say that, the electricity crisis is really, really bad, and this is what we need to do to correct it. But what I'm hearing you both saying, if I'm hearing you correctly, is that it could be really, really, really bad, and that the load shedding is actually preventing it from being super, super bad. Is that what you're both saying?
Yes, you are correct in that sense. It's true that it's bad, because we didn't used to have this before. Everything started around 2008, 2007, 2008. That's the first time we have the blackouts. We have that load shedding issue. We have blackout actually, because normally we take electricity for granted. If I go in and I need to have a coffee, I just switch it off and I have electricity. So we don't care much. It's only 2008 that we realize, these things is serious. We have to take care of this. So the problem we are facing is that we don't have much generation. So that's the problem. So our generation is old, and is breaking down often, right? So therefore, the only way to reduce the pain is to have this load shedding, where you relieve a little bit by shedding some load so that you keep the balance, like Tariq said. If not, then it will be worse down the situation. So the load shedding is really bad because it's affecting us, whether it's at the university or the business, or the normal life is affecting us, although we are used to that now, but it's still affecting us. It's not good, but the worst will be to not do load shedding and then everything will collapse. So you are right in that sense.
Well, what about the generation? So I assume South Africa is thinking about thinking about this very issue. So what can be done to generate more electricity?
The generation part, of course, is planning a power system for a nation or a country is a long scale project. It's something that is intensely tied to the country's development. One doesn't want to go there, but politics enters the realm. Large government departments and how they do things come into it, how planning happens. Planning in terms of generation capacity, increasing it, the direction of which direction they are going, adding more renewable energy. Is renewable energy what the country wants? Nuclear energy and the debate around that. Those are things, hard things that needs to be actually discussed and actually brought to the table. And unfortunately, those are also contentious issues. Those are not something which we likely discuss technically because it has certain other political implications, industrial ramifications, and so on.
So I suspect that this is probably a political issue around the world, right? Because you're balancing these multiple constituencies, but at the end of the day, people want their electricity to work.
A good example there would be the UAE. If one were to look at a small nation with a resource which they want to sell, which is oil and gas. So for their energy, they burn it to produce the electricity that they need. And so if they continue burning it, they're basically burning the very thing that they want to sell. And they've got a growing nation. And if you look at Dubai itself, 27 gigawatts. I mean, that's one city. So that's phenomenally, I mean, the amount of power that Dubai requires is amazing. But in so doing, they went nuclear. So they now have their 7th nuclear power plant, which they are introducing into the mix. So it's not an easy debate. It's not something that is fraught of political problems, but it's something that I think one should have. If you really want to reduce the carbon emissions, that is one way of producing a lot of power. And then, of course, there's gas. I don't know if Komla would like to add on to that.
Yeah, I think, you see, the problem we are facing here now in this country is that we don't have the generation, okay? And then if you want to build, for example, a coal-fired generation power station or even nuclear power station, it takes years, more than 10 years, okay? So we are not going to solve our problem, our load shedding problem now by building, coal-based power station. It won't work. It won't happen, okay? So the only alternative that we have is to bring in renewables. Of course, there's a lot of voices that are saying that the renewables, they are good. We know that. In terms of the pollution, there's no pollution anymore in renewables. But at present, they are still expensive. Okay, the price is coming down, and also we cannot bring them as soon as we want. Okay, so it will take at least 2 years to bring in renewables into the system. So what we need in South Africa is we need a mix of energy. All right? So people are saying, bring a lot of renewables, we need more. That's true, but there are a lot of concerns in this regard. So one concern is that renewables, they are not always there. Okay, they are not dispatchable. So for example, if I want to generate, if there's no sun, for example, I cannot I cannot generate if I have solar power. If there's no sun, or wind, if there's no wind, I don't have power on that. Okay. So the problem with renewables, they are not there all the time. So we need to have what we call the base load power station. For example, nuclear, coal-based or gas. These are base loads power station. We need to have those, and then on top of that, we need to have renewable energies. So the renewables, we need to bring in more renewables in order to, to be able to cope with our situation now. The problem in South Africa is it's a little bit slower, and also, of course, it's also the cost, the issue of cost that is affecting this.
But not to put you on the spot, I think that's an interesting answer. But let's say the president of South Africa was on set with us right now, and the president said, that is terrific, but we need to solve this issue today. This president or any other president for any country, what would you say, Mr. and Mrs. President, Madam President, what are you exactly advising them to do?
So one problem, one thing is the power station that we have. They have to maintain that so that they are working. So the problem we are having now is that we have a lot of power stations that are not working. So if we can keep the power station working, we are going to save a lot, because we have a lot of breakdowns in the power station. So we are talking about energy availability factor, which is very low at present. Now is around 60%. Last month it was worse than that. It's improved a little bit. So one of the things we need to do is the power station that we still have, keep them working so that they don't break down. So we can monitor the power station to see what is going on so that we can detect very quickly what is going on so that we can keep it working. And the other thing is to bring more renewables. For example, encourage people themselves to have renewables. For example, at my home, I can have solar PV, and that will reduce the take from Eskom. If I have a solar PV at my home, you have at your home, most of the people have, that will reduce the need. So we need to bring in more renewables and energy into the system. Of course, one of the problems, Eskom is a little bit afraid to be too much renewables because the system was not designed for that, right? So if you bring it, if it's too fast, also that could create problem, right? So there's a limit that you can reach at the moment, and so in the future, what we need to do is what we call smart grids. So we have to improve the power system, make it so that it's resilient, and it can support more renewable energy.
The current grid that we have we're talking about generation stock being increasing new generation capacity, new builds, maintaining the old ones and refurbishing. But the transmission system itself is something which needs a major look at. I mean, we haven't really overhauled the transmission line system to keep track of the current developments and what we are going to add on. For instance, in the Northern Cape, it is the best area for solar power generation, and it's got a lot of sunlight, and the yield there could be quite high. Unfortunately, the transmission lines running through there is not capable of taking any, or we can't evacuate the power that we want to add onto it because it won't be able to handle it. And this is one of the things that we need to, as in terms of the energy sector, address, and also make sure that we have a look at the transmission line system. And of course, a smart grid is a technology in which we can mitigate with substation automation and everything else any of these problems and faults that would occur if we do happen to add too much intermittent power as well onto the system. Because if we look at solar and wind, it's intermittent. So some things, it's like having a flip switch on a system. It goes on and off, on and off. And that in itself, electrical engineers, we would call that, is a potential for resonance and all sorts of other things to happen. So we look at that within our aging power system, and we'd say that we also need to look at the transmission line side and how to improve that.
We are at a university. What courses could students take to learn more about this and to get involved in helping your efforts and South Africa or any other country's efforts to help reduce some of this disparity?
For high school students, for example, we are looking for maths and science. So they have to take that at the university level also. For example, in our first year students, we want them also to know math and physics, because most of the things we are doing is based on mathematical modeling, on physics. And so basically that's the courses that they need to take. In the first year, there's also control, how to control a system and so on. These are the courses that require. Of course, English. So English is not a requirement, but it's needed to be able to explain or discuss what the students have done. But in general, we want them to have math and science to be able to do that.
Yeah, from the Energy Institute side at the Cape Peninsula University of Technology, we introduced a program called the MEng in Energy, which looking at the higher end, looking at people that already are graduates within the and normally you need within the energy sector a mix of individuals. We have the various engineering disciplines: mechanical engineering, electrical engineering, chemical engineering, and of course civil engineering. And from these disciplines, there are different ways in which they would look and interface with energy efficiency, energy production, generation, and transmission. So we sort of looked at that and created a master's level course where your entry level could be mechanical engineering, electrical, civil, or chemical, and we would give you a broad-based coursework which unites the disciplines but make use of their individual expertise in specialization. So we called it the MEng Energy, which is a master's in engineering, which is transdisciplinary in this case. And that sort of is a way at bringing the high-level student from various disciplines onto a platform where they are now interfacing with the modern world. They are looking at blockchain in energy. They are looking at the smart grid. They are looking at renewables and energy access and all the things. So this is what might not be covered at the undergraduate level, would now be looked at a level where we have the more specialized engineer and the management level, so that when we look at the future, we can actually see that there could be individuals that would take this on with a different perspective.
Thank you both very much. If you would like additional information about what we're calling Electricity 101, please go to cput.ac.za or uct.ac.za. If you'd like to send a note to me at the show, please go ahead and do so by sending an email to highereducationtoday@topcolleges.com. And thank you for watching. We will continue to bring you quality discussions about important matters in today's college and university world. I'm Stephen Roy Goodman, and you've been watching Higher Education Today.